Let's see, is it 9 o'clock?
Yeah, it's 9 o'clock.
So good morning, everyone. I was making somewhat light of the note taker situation earlier, but we really cannot start the meeting until we have note takers. So I'd like to ask for two, one to do the first half of the meeting and another one to do the second half of the meeting on the Etherpad. And we really can't get started until we have volunteers. You want to do the first part of the meeting? Okay. I'll tell you what the split point is in a second. Now we need someone for the second part of the meeting. Bastian, do it up through the disaster scenarios draft by Jan, and then we'll switch after that. How's that? Thank you. Second note taker, please. Alex, thank you very much. Wow, that was great.
Thank you, guys.
Thank you very much. Saves us time and effort. So Etherpad for the minutes, please. And anyone else who wants to get on the Etherpad and add to the context, that would be, of course, welcome. Oh, second part is starting with the requirements of challenges for IoT over ICM with Ravi. Okay.
There is another slide with those.
He's displaying, not me.
No, I am.
Oh, you are.
But this is not the full agenda.
Right, no, there's another
So
page. That's why I put the split point there.
Okay, good.
Okay, somebody want to start things off?
Okay, so yeah, this is the usual IPR policy, so similar to the one in the IETF. If you are aware or see any IPR mentioned that you know, please let us know, speak up in a timely fashion.
Oh, you want to start?
No, not yet. Can you hear?
Oh, here.
Next slide. Okay, so this is Icnrg. There's a mailing list, a wiki page. We're using GitHub for creating documents in the group. This is Dave Oran, Börje Ullmann, and Dirk. We have non-takers, thank you very much. Next slide. Okay, so we have a, I think, really cool program today. It's also quite packed, so we need to ask you to kind of stick to your assigned time. So I'm not going through this now. You see it all on the agenda. Next slide. Okay, so you probably have, if you're on the Icnrg mailing list. Next slide, please. You probably okay. Let me do this first. Okay, so we had a Sunday interim meeting. Some of you have been there. It was really interesting. So things have happened. So we get updates from Cisco regarding their FIDO ICN open source project. We're going to talk about this in a second. Lisha reported on the NDN community meeting that just happened last week. A presentation on using ICN in LTE by Prakash. So I'm not sure if you've seen that there was a side meeting on the so-called glass-to-glass like internet ecosystem, so a video distribution approach in the IETF on Monday. We got a kind of pre-presentation of that on Sunday, so that's also in our minutes. If you're interested in that, check it out. We discussed about NRS. Transport API ideas by Börje, and we also looked into the current status of the terminology document. So we have been progressing this this week, so in additional meetings. So expect an update on this soon. We didn't do the backouts. Okay, so this is so if you're on the Icnrg mailing list, you have just gotten an email by Luca on the availability of the Cisco ICN software. Related to that, you may have heard that so the ICN IPR that was previously owned by Park has been acquired by Cisco just very recently. So there was an announcement around Mobile World Congress, and so this basically means Cisco owns the IPR now, and they are applying their usual IETF policy on IPR. So that means it's licensed under rent conditions. And to make it clear, this also applies to experimental RSCs. So what we are aiming to do here in Icnrg. And so, yeah, related to that, Cisco had ICN implementations already. They are now also acquired the Park software, and they put all of this into the Linux Foundation FIDO project, which is basically around an efficient software switch implementation. And so there is a sub project in FIDO called Community ICN, CICN. So that is open for institutions, companies to join. So if you're interested in that, so if, for example, your company wants to influence what's happening there, check it out. I think it's a really cool project, and it's a good opportunity to say advance industry collaboration on ICN. Not limited to industry, but so typically that's what happens in these larger projects. So license is Apache 2.0. Okay. Right. So with that, we thought it's actually a very good time to resume the what we called harmonization effort. So we kicked off some work last year. You may have heard of that. Was the attempt to first of all understand the differences between say the two main implementation or approaches. So CCNX versus NDN. We started it like a task force, if you want, that were like discussing regularly and trying to understand why are things different, what is actually different, and so what is the reason for that. So this slowed down a little bit at the end of the year, also with the say situation in different companies. And so we think now we have a very good basis to start this up again. And so we actually did this already this week. So had some discussions with like people from different groups, and so everyone seems to be really enthusiastic about it. So what is going to happen is we are planning to have like weekly calls on that. So this is of course open to the community. So we'll announce the details later on the mailing list. So the purpose of these calls is basically to really look deep into the say different approaches and specifications. So and then discuss the differences. So it's good if you want to participate to be familiar with these approaches. So, so we are doing these calls. We are thinking about maybe also having a dedicated virtual interim. So teleconference, possibly in May, so before the IETF. And the hope is that we get something out, so I say more complete draft well before the next IETF meeting. The long-term goal of this is also to, help us to eventually arrive at a unified set of specifications in Icnrg. And for that, Icnrg basically plans to be the place where people from FIDO share their ideas, and we're trying to basically also link the FIDO activities to the ICN specification work. And so with that, we hope we have a good basis. So we have software, we are going to have more mature specification. So with that, we are hoping to have a good basis for like more experiments, more cool work with on ICN. There are a couple of upcoming events. Of course, you are probably aware of the ICN conference in September. That's going to be in Berlin.
Get your papers in.
Yes, so you can still submit papers. It's going to be a real cool event. So we are co-locating this with several other activities. So for example, there's going to be a Riot Summit, so the IoT operating system people. We are going to have the Thing-to-Thing RG people there. So if you're interested in IoT and ICN, this is the week this year that you don't want to miss. There is also the Infocom workshop on name-oriented mobility again. So this time it's in Atlanta in May. And there is a say ICN multimedia workshop at IEEE ICME in Hong Kong in July. And actually, I forgot what I should have said. There's also going to be a ICN Edge computing workshop at IFIP Networking in June.
Oh.
Sorry, I forgot to mention that. And
That's because it was yours, right?
Yes. Yes. That's it. And talking about edge computing, I'd like to invite Yves to give us a presentation. Yeah, I'm too modest. That's no problem.
Just fix my computer.
Okay. I'm Eve Schuler from Intel, and I work in the Internet of Things business unit, but I'm an alum of Intel Labs, where some of this work began. Even without the slides, I can tell you that, I'll tell you the backstory, which is that for a lot of years, we kept asking Intel to make a bigger investment in ICN. We kept making it all the way to the final round of their sort of university research office considerations, and we'd be a finalist and we wouldn't get the funding. And it was really discouraging. And after 3 years, the fourth year, we said, forget it, we're not applying. And wouldn't you know it, that year they approached us and said, hey, we finally would like to fund the ICN effort. So the moral of the story is never give up, never surrender. Eventually your company or your university comes around. I should point out that this presentation is in conjunction with my partners in Intel Labs, Katyayani Srikanteswara and Jeff Forster. They're in the wireless lab run by Vita Ilderim, if you are collaborators of theirs or know of them. Next slide. So there's a larger backstory that I'll start with and then tell you more specifics about the program itself, and time permitting. Oh, and of course the next steps. Where are we in this process? And then time permitting, I'll give you a larger. Oh,
You can run the slides yourself.
oh, perfect. Okay, great. Okay, so starting about, I don't know, sometime around when Van Jacobson gave his seminal Google talk about ICN and we found religion, we started thinking about how do we use this new technology. And at the time, I was in the Energy and Sustainability Lab in Intel Labs. And so naturally, we were trying to understand, gosh, how do we put this into smart spaces? So what was appealing about that was that there was, and there continues to be, some debate about whether or not there's applicability of ICN. You know, how would you deploy ICN in a broader internet, wide area internet? And so this sort of sidestepped that whole issue and said, great, we have our own administrative domain at the edges of these networks and these smart spaces, and we can play with it and we can change our addressing and naming scheme all we want, and we don't have to worry about whether our ISPs are going to deploy it. So that was some of the motivation here. In addition to the fact that we could immediately see that ICN made a good bedfellow for the kinds of publish, subscribe, comms bus that we needed in these smart spaces. And so we went through a series of experimental proof of concepts, the first of which was in the smart home. Again, we were trying to understand energy efficiency. Oh, I should take note of time. And what we were experimenting with really from the networking standpoint was, what are the requirements as a user, as an IoT application? What are the requirements presented to ICN? What does the pub-sub interface look like? What do the security privacy interfaces look like? After having completed that, we moved on to saying, oh, well, what if we deployed this in a smart city? And so we had an experimental proof of concept where we were working with some of the DOE-funded projects in Austin, where we were looking at coordinated electric vehicle charging, because if everybody charged their cars at the same time, actually it's not very good for your transformers at the edges of the network. But what we could see is that all this energy domain data that with high frequency leaks information about all kinds of behavioral patterns in your life. And so we're really concerned there with how do we couple ICN with data privacy. And so made some proposals on that front around attribute-based encryption. There's additionally a group in Germany, Intel Labs, that was interested in the ever-present problem that how do you do all these software updates when you've got billions of devices on the network. And so they wrote a paper about the updaticator to explore that and using ICN as the fabric beneath that. And then more recently, work on really the problem that there's so much data. It's still too high for me, which is remarkable. Yeah, this is good. No, now it's too short. So the problem with the fact that there's so much data is that you can't get it across the network. So instead of using ICN to send around sensor measurements, let's use ICN to send around the compute, the executables that you need in a dynamic manner across the network to compute and to perform analytics on the data. So I don't know if you can tell, but we really weren't looking at the innards of ICN. We were looking at really kind of the use case driven requirements as applications to ICN. And we were deferring to all of you here for your brilliance to tell us about, which ICN implementations to use and so forth. And so some of this works, you use the CCNX open source code and or at least, sort of early work was CCNX and the latter work was using NDN. And over this time, we sort of grew this partnership between the business unit and the labs because the business unit said, hey, this stuff is really cool. Why don't you come into our product group and see what you can do with it. And as of today, there is a proof of concept that's been released by our retail division using some of this work. So with that, we, as I said, we kind of appealed to our university research office. And in conjunction with NSF, they have put aside $6.5 million for over 3 years to fund 2 to 3 projects. And the intent, of course, was, since we've already been looking at how do you use ICN from above, what are the requirements from below? And so this is why the focus is largely on wireless edge networks, looking at really ultra low latency applications and massive deployments. And the 3 dimensions of focus are ICN-enabled wireless device endpoints, the infrastructure itself, and data security and privacy, with the hope that there will be experimentation from a clean slate approach, meaning in addition to overlay ICN approaches, also some native work. So the research goals, inside of the presentation, I have several slides, several pointers to actual materials, and this is the NSF call if you'd like the gory details, but basically let's create a new integrated approach for wireless networks. Let's address well-known fundamental challenges in wireless data delivery. let's not only demonstrate, but the long-held and elusive challenge of quantifying the benefits of the potential, not only of ICN, but the combination of ICN and WAN, wireless edge networks, and evaluate this in terms of realistic deployments and implementation complexities. So really, what was driving this, of course, as I said, my partners in Intel Labs are from the wireless team that's focused on 5G and beyond 5G, and all kinds of use cases from autonomous vehicles and drones and so forth, and taking advantage of the fact that ICN, because of its caching, is much friendlier to the situation where the source becomes inaccessible but the data is still available because it's been cached in the network. And really exploring the issue of, where and how is this data flowing? The IoT sort of is disruptive in the sense that the data originates at the edge of the network and it's flowing towards the core. If it flows at all, we know that it's causing tremendous congestion in wireless fabrics, both cellular, Wi-Fi, and even in mesh networks, particularly when we're looking at the world as a place where every light bulb, smart light bulb, is generating video. So if everything were a camera, could we get this stuff over the network? It may not flow at all. So I'm not going to go over this, but again, I have a pointer to sort of what's driving this from the 5G standpoint. There are many very interesting metrics that are kind of data rates, latency, kind of connection density, and energy-driven metrics that make 5G and 5G plus a very interesting playground for provability and to vet ICM. We anticipate that in a world where things are highly dynamically reconfigurable, that ICN will be friendly to our applications, late name binding and so forth, and that we're not only looking at cellular and Wi-Fi, but also mesh networks. That star topologies at the very, very edges of the network are not as interesting, but they do, mobility presents very interesting patterns in that it scatters your data in places, and that ICN is a net that can sort of collect that data. And then there's a big discussion within our group about the liberation of data, and that ICN is sort of the cusp of that, meaning if you think about what ICN is actually doing, it uses additional attributes about the data that you're sending across your channels to make better routing decisions. And if we can liberate that meta information, it can be used not only in the routing, the inner networking layer, but in the layers below it. And but why not use that information more widely, period, architecturally across any part of the architecture? And so that's sort of a part of the bigger picture. And the other thing that's interesting about ICN is that it, at the moment, is coupling routing with caching, but why not use that meta information to perform optimizations about where that processing should go? Since I've already talked about how we're moving the compute to the data, maybe we can be informed about where to pin both the storage and the processing. Along the lines of our friend at University of Basel, what is his name?
Christian Schunin.
Yeah. And so Intel's interest in ICN is that, really to ask this question, how far away from prime time are we? Obviously, we look to the community and ourselves to continue to develop practical use cases. And we're very heartened to hear that the harmonization efforts are going to continue because we feel like that is a huge stumbling block. And we are hopeful that there will be metrics, whether hard metrics or soft metrics, that'll help us evaluate, in what ways is ICN an improvement over IP, or in what ways might the combination of ICN and IP present some improvements. So, these are all our motivations: evaluating its potential industry solution, helping us to realize 5G plus networks, meet these ultra low requirements and massive deployments, and then enable fog computing. Do I have another minute or two?
Yes.
Okay, terrific. Okay, 5 minutes, great. So the next steps is that we're on the cusp of announcing who our awardees will be. So mid-May, and we are targeting 3 teams. And so the bigger picture, I've said a little bit about that as I've talked, but I wanted to give you a slightly longer story. For those of you who attended the Thing to Thing workshop the other day, and there were all these breakout sessions, you'll know that I was very loud. And when it came to the edge fog discussions, and that's because we've been looking at this for a while, the reality that many IoT applications generate their data at the edges of the network, and yet the network was designed for, the core data flowing from the core to the edges. And so how does that disrupt what's going on? Well, what we're seeing is that cloud functionality in the way of storage, compute, and analytics, the networking, the control, all of that is migrating, if you will, to be more proximate to the data. And there's quite a bit of data, if you believe, some of these reports, about 40% of the IoT data that's created will be stored, processed, analyzed, and acted upon at the edges, so it won't flow anywhere. And the root of the problem is that it's not that the backend cloud is unsatisfactory in its performance, but it's actually unusable, and that this is when data that's generated has a temporal component, or the control loops are delay sensitive, when there's high volume of data, as we experience with ever more sophisticated cameras and video and other multimedia and real-time data, that there's a trust sensitivity component as well. There are many use cases where, think about healthcare, think about manufacturing, where you might not want to move your data somewhere else. And then the reality that when you're disconnected, you actually don't have access to a backend cloud, so you have to understand how your data is going to be managed locally. And we also, in the Thing to Things working group, talked about, and this is very appropriate to wireless also, is in the energy, well, energy is consideration as well. If you're sending all this stuff across the network, your supposed constrained devices at the edge have a consideration for energy. So you can see there are many examples. They're not so futuristic. They're actually here and now. And what is really provocative to us is this idea of when you have these flows, and they do flow back, but maybe they don't flow back all the way to the cloud. What does the edge start to look like? It's not that we simply have a backend cloud and an edge cloud, but it's very likely, if you participate in any of these other consortia, like the Open Fog Consortia, or in China there was just Edge Compute Consortia, and there's an Open Edge Consortia. Everybody's talking about the fact that really the way fog computing is evolving as a definition is that it's likely a multi-tiered cloud of clouds. And so that's a really interesting architecture for us to play with. And that when the data flows in the reverse direction, at these aggregation points, maybe the proxy for each of these clouds, what is it doing there? And how does ICN in particular, ICN has some very interesting challenges. The data is transformed, whether it's to fit the data over the pipes in the way of compression or subsampling or transformation, or whether it's analytics to analyze and throw away the stuff that's useless, or go from the video realm to events or data. They're much reduced in bandwidth. In any case, so ICN has some provocative challenges of what does the naming look like as the data gets transformed, as it wends its way back to somewhere where it might be archivally stored, if it's stored at all. So our big picture, and these are our kind of bigger questions and provide the context for the ICN-WEN program, and these are all a series of questions because, of course, that's why we're funding the research, is what does this combined network compute storage architecture look like? What's the impact on, as you reimagine a cloud or a data center at the very edges, whether it's a physical or logical data center? What are the implications for privacy, security, and trust? And what does the control plane look like? Is it a software-defined, self-configuring cloud of clouds? That's my question to you. And that really, how do we make it so that our data and the metadata is really more accessible, not just to the routing layers, but to other parts of the architecture, while at the same time safeguarding that information so that it's only revealed to those who are privileged to see it? So my questions to you as a community are, can we figure out ICN's role or its relationship to these fog data flows within the clouds, the north-south between tiers in the fog, which is this reverse CDN kind of structure that we talked about, or east-west across collections of clouds that you might encounter, say, in a smart city, which has different data sets of measurements around environmental data or traffic data and so forth. And the terminology that people are using about the liberation of metadata is maybe a smart data or a smart object framework. I know that the IAB hosted last year a workshop around semantic interoperability. That's another term used for this, but there is some sort of shim or ecosystem partner around how do we manage these objects, where everything to which you can attach an identifier is an object. And how do you go from a high-level object to a name, say, in ICN? What's the relationship there? And when data is transformed, how do we keep track potentially of the lineage of this data? And it's the relationship of all of that to the trustworthiness of the things that we manipulate and manage in the internet, particularly the data. How do we grow that trust in such a decentralized manner? So those are my research questions. Talk amongst yourselves. I expect a report out soon. Anyway, so there you have it. That's our program and the larger story as well as our backstory. Any questions? I think you probably have to turn on the switch.
You have to put it very close to your mouth.
Yeah, sure. So hi. So you said the grant is going to be distributed to multiple teams. So I mean, when you say ICN, generally is it Indian CCN or are you considering other?
We are being agnostic. We don't much care what flavor. I mean, we're actually trying to be. So one of our criteria for the selection is that we don't want it to all just fall in one camp, right? We really want to have the variability of expertise and approaches for these architectures. So we're not looking for any particular brand of ICM.
Okay. And the other thing is, you said 5G plus, in the sense like you're looking at more radio access kind of networks, I would assume, right? Or is it like more cellular kind of?
Again, we are trying to be agnostic as to what kinds of underlying wireless, and yet to select a diverse collection of approaches that people are using, sort of different contexts. Some of what we've done is that we've tried to organize it by use case. So every proposal has pitched 2 different use cases to try to demonstrate the architecture that they propose.
Okay. And is there any specific focus on specific application scenarios?
No, except that they should be, that they should exhibit, they should have some requirement for latency and that they are scalable. Those were the 2 sort of ends of it's 2 different attributes that we wanted present in the one or both of the use cases, which is why sometimes people were looking at one or the other and then had 2 different use cases presented.
Okay, sure. Thank you.
Please say your name when you come to the mic.
I'm from Nokia. Thank you. It was very good presentation. I liked a lot of it. Can you tell more about how do you move the processing with the data closer to the edge? What kind of mechanism?
What I meant by that was that in this, I like to call it the cacophony of the IoT, where there really are billions of devices and they're highly dense. Things are densely around you, whether those are sensors or whether those are logical entities. As things encounter each other, they may or may not know how to communicate. And so they may need on the fly to download services or applications, executables. And so really what I meant was when you move the compute to the data, it's in that form. Now, the way you do that may be ultimately through virtualization or other containers and other techniques, but the first step is figuring out how do I talk to this thing that I've encountered, how do I interact with it? And so what we have been doing experimentally, which is by no means what we expect to be the end product of this research program, was simply to experiment with analytics libraries that we make available as a service, and that applications, once they figure out that dance of how to communicate with the things around them, can then download on the fly the executables that they need and use ICN as the mechanism to disseminate that.
Okay, good, thank you.
So line is closed. One more.
So when you talked about,
Your name, please.
Randy Turner, with Icnrg, when you talked about how far out is this?
What's the this?
How far is this for deployment? How far out is this technology realizable, usable, in a grand scale?
Well, this is why it's so important that there are these open source and publicly available archives of data. I mean, not of data, of source code for these implementations, so that experimentation can happen now. And this is why the point about in the edge network, you own the edge network, and so you don't have to wait for the rest of the internet to deploy this stuff. You can deploy now.
That's right. It's just that there's words in the slide deck, ultra low latency. So ultra low latency is something in the IoT so we haven't built out the IoT yet. And the IoT that we're building at the moment is significantly high latency in certain areas where it's lossy and things like that. So
Absolutely.
it'll take a couple of, I mean, we're building.
Yeah, well, this
that
is
out
why
now,
this is
so-
3 years and
Well, okay.
and
so-
even longer.
Right, so-
This is the ramping up of people's academic projects, right?
And I
Yeah.
think that's kind of where it'll live, in kind of a virtual overlay kind of a network for a while, because we haven't built out the high latency version.
But
of
we
that.
certainly have received proposals that are both overlays and native ICN,
And-
so that's
And
exciting.
I remember talking about this with when I was at another company with Van and his team, and the MIT Media Lab. We're also looking at pervasive wireless solutions, and this is all great. I love the idea. That's why I'm here. I'm grappling with in 3 years dealing with Van always just say it's a pull, not a push. We're not injecting data. We're
Well, I think
optimizing
later in the
pulling.
program, you'll hear more about augmented reality and virtual reality, and those are some of the key applications that we have heard proposed
So-
for usage
Sorry,
to
really hate to interrupt, but we have to move on. We have really other cool stuff coming on.
Okay.
Yeah.
Is
Maybe
there-
you can grab Eve after the session.
Is there one organization that owns this?
It's a partnership.
Icnrg.
You're here. We're here.
Yeah, but also this being the proposal is NSF and Intel.
Okay, thank you very much, Eve. Also, thanks Intel and NSF for doing this. It's very cool. Sorry, line is closed. So next up is Dave with another a cool opportunity for doing more ICN research.
So we really have to adjust the mic here.
Slightly.
Okay, so I'm going to be very, very quick here, because I don't have a lot to say. It's just a quick inform to the community about something that's going on. So DARPA issued a few months ago what's called a broad agency announcement for proposals around a new generation of multi-level secure tactical battlefield and other forms of tactical networks. And the PI at DARPA somehow thought that ICN might be an interesting thing to try, given how many times both DARPA and the US military have failed dramatically at actually working tactical networks. Any of you US citizens? Okay, you have all spent at least $150 of your own money on non-working tactical military networks as taxpayers in the US. So they're going to try again. Lovely. You can find this announcement at the URL that's on the slide. I highly recommend you read it. I would say, it's like 70 pages, of which 50 are completely irrelevant because they talk about contracting niceties and things like that. But the technical meat of it is actually reasonably interesting. So what they want is, by the title, Secure Handheld Devices on Assured Resilient Networks in the Tactical Edge. So let's unpack this second. First of all, it has to be a multi-level secure system in the military sense, right? That is possible to have compartmentalized security across multiple security classifications and across coalition members from different organizations. So it's not even a single organizational multi-level secure, it's a multi-organizational multi-level secure. Second, it's targeted at tactical systems, which means tactical mesh radios at the edge, as well as COTS LTE style radios, because the military is starting to use a lot more LTE style technology, although not actually operated by service providers, sort of deployed directly by the military. They're looking for a major improvement over existing systems in terms of the resilient operation of the network. And they're also looking for, I didn't put this on the slide, but it's very important. Right now, when they go to deploy a tactical network, a bunch of people gather everything into a warehouse and spend 6 weeks configuring it. And then they hand it out to everybody, cross their fingers, and then it doesn't work when they get it in the field. So they want something that is, you know, I mean, their pipe dream is something completely auto-configuring, which isn't going to happen, but at least something that can be incrementally configured and put together in the field or close to the field without these long delays. And they want a field testable system, not a research prototype. So there's some research aspects to this, but some of this is fairly hardcore system building. So some administrivia. Don't take my word for all this. I might have some of this wrong because I haven't been actually involved. I'm not a DARPA person or anything like that. So the proposal deadline was on March 15th. The budget is about 30 million over 3 years. The speculation is they're going to fund 2 proposals of the ones they've gotten at about 15 million each, so 5 million a year for 3 years. And they've received at least 9 proposals, so that's really quite good. So there was a tremendous amount of interest in this. So what might be interesting about this effort from the point of view of Icnrg? We've looked a bit at keying in the Icnrg, but we haven't really looked at secure group keying in a multi-level secure environment with partitioned, not partially trusted groups of people. The second is, let's face it, the ICN community has looked at QoS, they've seen how it's failed in the internet many, many times, and everybody's sort of been waved off and said, oh my God, let's not go down that rat hole. But this project is going to try to attack the quality of service problem head on, but remember, it's a military approach to quality of service, right? Which means admirals setting golf dates are more important than soldiers trying to fix the enemy, right? Okay. It's strict priority and all those sorts of things. So one of the things we get with ICN is that in IP, you can prioritize requests and packet transport, but you can't prioritize information. So certain information is inherently more important than other information. Since we have names exposed to the network now, we have the opportunity to do prioritization and differentiated services based on classes of information. Third, how do you get the kind of delay-tolerant network properties that the DTN community has come up with in an ICN protocol without sort of flipping over to the other side and reinventing DTN? And lastly, how do you deal with mobility across both mesh tactical radios and COTS LTE style radios with satellite uplinks? You know, everybody sort of looked at mobility in the context of a given kind of wireless and not across wireless systems. So you may have questions, but I don't have answers. So if you want to come to the mic, you can ask anything you want, but I'm probably not going to be able to answer it. Thank you.
Okay, thanks, Dave.
I suggest we ask Thomas to come up in the interest of time.
Yeah. So while Thomas is coming up, there's also actually a current call in the EU Horizon 2020 program on IoT testbeds and frameworks that is closing on April 25. So if you are interested in doing something in ICN IoT, that's also another opportunity. Okay. IoT.
Yeah, thanks. Oops. Okay. So hello, my name is Thomas Schmidt from Germany, Hamburg, and this is joint work with the Berlin group. I want to report about 3 things today. One is, first of all, make a little bit a statement about what problems we are looking at, problems and scenarios, and then I will report on work of porting, maintaining CCN Lite on Riot. And finally, work on top of this, how do we think to organize content dissemination in the IoT. So problem space we are looking at is, we are looking at constrained devices. So that is one of the key problems. We have very few kilobytes of memory in the devices. These devices have possibly long sleep cycles, so they are offline most of the time. If they have storage is likely not to be the problem. I mean, if they have flash on, a flash chip, then this is probably rather large. So we can cache on this. Communication. The communication problem we are looking at is that in this ICN or NDN CCN request response scheme, event triggers are insufficiently supported. So we want to develop this without inventing or adopting a push on the data plane. And the other problem in this area is making data available timely at lowest price, and also looking at some sort of prioritization. I'm not sure whether it's the same what Dave just mentioned about the military. Finally, a thing that is side remark today is we have names. We're looking at name-based routing, but it is relatively unclear what the context in the structured namespace is actually good for. Is this name ownership? Is it administrative ownership? Is it topology? Is it the context of access? So that is something on debate also in our group. Typical IoT scenarios we're looking at is a sparse deployment, at least of fixed nodes, maybe very many mobile nodes. Coverage is inhomogeneous, so you have areas where there are almost no nodes, there are areas where you have a lot. Networks may tend to partition if you have mobility among the nodes. They may separate for a short time, may rejoin again. Mobility, of course, I already mentioned, and that leads to intermittent connectivity of nodes or groups of nodes. But there will be, or we see in these scenarios, selected uplinks to some clouds. So there is, from time to time, there is an uplink, and there is an interest to report to a cloud environment, whatever this is. Maybe also an edge cloud. What's this? No, that's spurious mail. So what are the opportunities with ICN? Definitely mobility, support of mobility, even though it's not easy. It is something that has high potential. Security is something already mentioned in environments we are looking at where we have alarms and stuff. It may be very important to be reliable and to secure actually information. Network management, having almost auto configuration, auto management is an important thing, and of course the network caches are something that we consider as one of the key solution to replicate data and make them accessible from the near to members of the network. Shortcomings, routing on names is difficult. Long names are difficult. And one should repeat once again, there's no local way of deciding on aggregation with name-based routing. So that's a strong challenge. FIPS tend to be too large, so there's work needed on limiting FIPS and also the churn in FIPS. Another area is link layer models. Originally, NDN or the original perspective was point-to-point links or broadcast, and we need to make this more sophisticated and to adapt to the layer 2 requirements in low power lossy networks. So that's how it all started. That's already 3 years ago. We started to reported the CCN Lite software on the operating system Riot. We are from this Riot group, and started some experiments with this, and that was already published in 2014. At that time, we had the CCN Lite software. It had about 1,000 lines of C code, and on the Riot system, It required 16 kilobytes of RAM and 5 ROM and 5 kilobytes of RAM. So it was very tiny, very lean, and that was also promising. That was much more efficient than the IP6LoWPAN co-op software. We continued to work in this area for quite a while, and as time progressed, we also started discussions with the guys from Uni Basel, with Christian Schudi, whose group is the creator of the CCN Lite software, and we wanted to join forces, and this is what we are in the process now. So we started in the late last year. We started the joint development of the CCN Lite software. The objective is to have this as a maintained package on Riot, and that turned out to be quite a lot of work. I mean, to do it well. So we started a major code reorganization, new source code structures, and changed the policies of including files. There were tremendously many bug fixes, smaller, larger, but large pull requests in the GitHub. 56 closed so far. Doesn't mean much, but I mean, it was a lot of work done. And there were also a couple of features added to support IoT platforms. I just talk about this. We are currently, you see the URL here. We are working on a separate branch and hope to remerge this later on. So what are the new features? CCN Lite now runs on a wide variety of IoT devices, and that's actually via Riot. So you can wherever Riot runs, CCN Lite runs as well. That's basically the same as NDN. Yeah, Alex is doing the same for NDN. So that is a good, it's a real advantage. So if whatever device you have, if Riot runs on it, CCN Lite runs on it too. And the same goes for the networking capabilities. Riot has this generic network stack with a recursive API that is called Net API, and CCN Lite is built on top of this. That means you can actually deploy CCN Lite on Riot using either UDP as the upper layer, IP, 6LoWPAN IP, or any driver that is just a native driver to a wireless or wired network that is available, that includes the family of LoWPANs. Actually, there's also LoWPAN support, native LoWPAN support for CCN Lite on Linux now that we added this. Also, Riot supports multi-transceiver, multi-stack, so you can have multiple network interfaces, which gives rise to well, easily implementing gateways. So there's already an ICN MQTT gateway available, or an CCN Lite MQTT gateway if you want. So that's already available. There were extensions to CCN Lite. In particular, we introduced 2 new hooks. That is one on interest. So if an interest is received, you can implement callbacks, for instance, to generate content. So if I send you an interest that is actually an interest on some sensor value, you can generate content on the fly with the software now. And there's also a hook for cache management policies now. Roadmap, ongoing steps. We are building currently the build system for CCN Lite. That is tedious work. First of all, we have to separate out the code dependency to make this workable, produce the make files, and so on and so forth. This is just work. And then we want to integrate it in, or plan to integrate it in a CI that is actually. Or we are thinking of doing this in a Riot or more Riot-like way. The feature of the Riot CI is that you have that it's fully distributed and can test and compile and so on. This for different platforms, including hardware that is actually attached to the CI nodes. And currently CCN Lite runs runs with Travis, and Travis, as you may know, is not good if you have a lot of activities. Then it actually it doesn't give you much space on the infrastructure, and you cannot add add devices to it. Yeah, we need to do stuff on data structures to make it more efficient. In particular, the memory management is a problem. I mean, the CCN Lite uses as normal C software uses mallocs all over, and in IoT devices, mallocs are not so popular because you want to have a fixed memory size. You don't want the system to grow while it's running. And what we're currently working on providing a fixed size, dynamically usable memory pool that actually can trade cache to protocol state. So if you have larger tables, you have to reduce the cache and if you have small tables in the system, you can extend the cache. That also means that we need a limit on the name length. Which will be configurable, of course. Okay, so far and now something about what we're doing with it. I mean, it's not only to maintain code, it's also to do contributions in the ICN world. And we are thinking about the problem, as mentioned earlier, on how do we disseminate data properly, or how can we do this in a nice way. And there's also a new draft here. So we want to account for nodes not being present all the time, and we also want to avoid exploding FIPS. So the idea is basically how can we organize a nice publication layer for PubSub data for PubSub, and actually how could this work in ICN? Commonly, PubSub, the publication in PubSub is on the data plane, so you push data somewhere and then your system works with it. That is not exactly what we want to do in ICN or in NDN. And the paradigm is a request-response paradigm for several reasons, as you all know. I don't need to repeat it, even though there are a couple of there are a couple of proposals running around. Yeah.
Yeah, I just want to, Jan Seedorf, I just want to mention that I hope you're aware of the content-oriented publish subscribe work we did in the Green ICN project. There's this paper from the Göttingen group. It's called COPS, and we worked a lot on that. It's
I know COPS. COPS is a multicast mechanism. We are aware of this. Yeah.
Okay. Yeah. Just have a look into it. So there's a couple of papers we produced on published subscribed in ICN. Not me personally again, but
yeah, I know. We are aware of COPS. Yeah.
Otherwise, talk to Mayutano or KK. They will give you all the links.
Yeah, I know. Okay. So the question, what COPS is doing is basically it is building a PIM-SM distribution tree in the NDN technology, and what we're looking at in the moment we're looking at the problem. What actually happens on the control plane here? I mean, if you want to do something to make something available to the network, that's actually an issue on the control plane if you have name-based routing. And that is the point here is the control plane is the one that distributes routing information and distributes the presence of names. And the question is, how do we do this? I mean, we can do this by broadcast or so on. That's all not very efficient. The idea we pick up here is actually an idea we have published last year in the IFM networking conference, and that is basically that you install something that is we call this name aggregators, but that's not important. The point is you have prefix-specific default routes in the network that are distributed by points of meeting points or something. There are other approaches mentioned here. I forgot to mention COPS. Sorry, Jan.
It's okay. I don't have much stakes in that. I just wanted to make you aware of that. You are aware.
Yeah, sure. Yeah, no problem. So Okay, so next step. So how does it work? There's this point we call content proxy actually. That is a point that is the guy who is aware of a certain prefix. This prefix is announced by this point, and it leads to default routes in the system, persistent default routes on the control plane. So they're in the FIPS, they're not interests, not long-lived interests. They are just FIP entries, and they are typically they can be relatively stable if these points are stable. I mean, if they're not, if it's all mobile, then you have, of course, a lot of updates. If it is these are infrastructure points, then it's relatively stable. And what you can do now is, if you publish, you can announce to these content proxy points or rendezvous points or however you call them. And what you do is if you have a new name, if you publish something, you tell this to this rendezvous point. And this guy is then, if it's a cache, for instance, or a gateway, is then able to get the data, to request it. And we're staying in the fully in the request response paradigm. We are not working on a system that pushes actually data, and so we keep also the flow control and everything else. Otherwise, the publisher is, once this is replicated, the publisher is out. So it is not involved in providing data persistently. So the idea is this guy goes to sleep quickly. And subscribing to content is, of course, everybody has these default routes, so you can talk to the rendezvous point, ask for content, and there are different ways of doing this. You can either advertise names from this point. Again, these are not default names, but these are specific names. You can also write this in meta tables, or you have a periodic mechanism or something. That's not the big thing. So to come to a conclusion, we have an implementation, a first implementation that is based on the CCN Lite and something new, some piece of new software, which we call the name advertisement daemon. That's basically the thing that works on the control plane, advertises prefixes and does the control plane management. And we have a first demo with this content proxy on an Raspberry, and the rest on a low pan with small nodes, whatever, ARM M3 or something. That's basically it. Thank you very much.
Thank you, Thomas. So we can allow one question.
I have a question about opportunities of CCN for IoT. You list four good properties of ICN, right? The first is mobility, second is security, third.
Yeah, that was one.
Yeah. I want to know which most important property.
It depends on your perspective. I mean,
in your
and from our perspective, the most important thing is that you don't need end-to-end involvement for disseminating data, because in the IoT, most of the time the nodes are not online, and they like to sleep, and you still want to access content. But you can, if you are very much in secure applications, then probably security is the most important objective for you.
But the security can be achieved by many different projects.
Right? Yeah.
Mobility can also be achieved by many different mobility protocols.
Yes, but the point is how easy is it for you to achieve this? I mean, let's look at mobile IPv6. It's a beautiful protocol. It's elegant. It's fantastic. But it is in the IP end-to-end model, of course, because it's an IP protocol. So, but it achieves mobility. You're perfectly right.
Okay.
Okay, I think Thomas will be available for additional questions later on, and let's use also the mailing list to clarify some of these things. So next up is Alex with an update on the IoT activities in the NDN project.
Oops. So this is effectively to follow up Thomas' presentation. Oops. with updates on NDN Riot. NDN Riot is, we started this project some time ago, I think almost a year ago, and with objective to bring an NDN communication on a Riot platform. And there were a few goals, and I think Thomas already pretty much captured all of it, but there are a few a few specific ones. First of all, we want to do experimentation with IET applications and trying to do interesting things at the edges, as Eva was talking about. Support the kind of NDN packet format, but one kind of interesting goals or important goals we put is support security, data-centric security to some extent, support forwarding strategies to experiment with them. And of course, eventually we want to have be part of a Riot platform. It's just for the development. During the development, there's a few things outside. So I already presented NDN Riot last time, and this time is just mostly introduction of new features that we have recently added. So one of them is we have added the basic forwarding strategy mechanism, or like a callback. So when you deploying your application on Riot, you can either select a specific strategy that's already available inside the implementation, or add whatever forwarding strategy you would like. Okay, I'm not going to go over details. Another progress was we already had the implementation of asymmetric cryptography with a few patches that we added here and there. To support ECDSA signatures. They're kind of slow, and last time I presented that creating one signature on such a small device takes about half a second. Though it's slow, but for some use cases it's perfectly fine. Like for example, an example kind of did some over the napkin calculations is if the device, some sensor in a field measuring pH, and if we just taking one measure and secure that measure once a minute, like on a small battery, it can last for like half a year. But this is another mechanism, is a symmetric mechanism. Kind of, if you're a security person, you know this acronym, is to provide the security and authenticity and secrecy using the same operation. So we have designed kind of a few mechanisms, and if you're interested, I will be happy to talk more either during the question or offline. This is just to recap what is the position of current state of NDN Riot. So as I said, it's not yet part of the whole package, but you can easily start working with the NDN Riot. We already merged a few patches, not as impressive as what Thomas presented, but they're kind of, we're working more, like there will be more stuff coming. We also created a few example apps, and if you're interested in just getting started, you can try to get started even without your IoT device and play with the kind of emulated environment, and just first install all the dependency, and everybody can help you with, and just download. It's kind of, there's a fork of Riot implementation, but it's just the two patches and the kind of merged patches on top of that. You download the NDN Riot as a module, and then download these examples and go to any specific example and just type make, and it's supposed to, with some parameters, and it's supposed to compile and create this environment. You can run basic examples in virtual environment, just effectively running on this virtual devices, or you can, if you can get access to the small devices, you can actually flash it, and for the ping server, ping client, they will kind of ping each other. You're probably not going to see anything unless you connect something. So this is it for my recap. There are no more slides.
Thank you for this update, Alex. Any question? Okay, check.
I have one quick comment. I think this is really good situation, because in the process of figuring out how to sort of converge a lot of our efforts for ICN, it's really good to have both stacks available on the same infrastructure. So people can, see how different the applications are, if at all, maybe be able to run a same application on both, and actually dig into what differences might and might not matter. So I'd really encourage people who are doing research in the IoT ICN area to think about using both of these things. Thanks.
Oh, thanks.
All right. So next up is Jan with an update on the disaster scenario draft. So just to remind people, this is one of the research group drafts that we are adopted as an RG work item or research item. And so this is something we want to, you know, progress and publish eventually. So check it out. So actually, when Dave talked about the technical network problems, I think the disaster scenarios that Jan looked into are actually
yeah,
similar.
thanks. I was going to say the same thing.
Okay.
Yeah, thank you for the introduction. Yes, so this is a research group item, as Dirk was mentioning. I will get to that later. Oops, and now the mic is dropping. Like this, huh? This? No, wrong. Ah, okay. Okay. Seems to work now. Oops, sorry, Barry, can you make the slide full size again? So, as Dirk mentioned, this has been around for a while. So the research group has adopted this. I haven't presented in, I think, 2 or 3 IRTF meetings or IETF meetings, so I don't know if everybody's aware. I hope I'm not boring you with this. So we actually had a 3-year European funded and Japan funded co-funded research project where we worked extensively on looking into how ICN can be used in disasters, what we call disaster scenarios. And what we mean by that is something you can see on this picture there on the right side. You have an earthquake happening or another kind of natural disaster, could even be a terrorist attack. And after that disaster happened, you have certain communication links not working anymore. So you have what we call fragmented networks, and you have kind of a scenario where parts of the infrastructure are still working, but some parts are not, and you still want to have certain use cases. I have them listed here on the slide. We looked, of course, more intensively into that, but you can find them in the draft. So some use cases are like authorities want to inform people, okay, here's a problem, please don't go in this area, it's dangerous. It might be a nuclear hotspot like we had in Japan in 2011, you know, there were nuclear hotspots and the authorities wanted to warn people. Obviously, I'm as a citizen, I want to, average user, I want to inform my family I'm okay. That's normally what happens after a disaster or a terrorist attack. If you had the Boston Marathon bombing, people were trying to communicate and the networks were overloaded, these kinds of things you have. And of course, you want to be able, if you are a citizen, you want to be able to inform other people or even authorities, hey, I found a shelter, this is safe here, I found a problem here, these kinds of things. So basically, we're looking into a scenario where you have highly congested networks because a lot of the communication links are broken down. You may not have reachability of backbone services like DNS, like security services like you have in GSM, right? If I'm roaming in GSM right now here on my phone, if I cannot reach my home network, I'm not going to be able to make a phone call, right? So our starting point was, hey, ICN is we think ICN is really good for this. And I actually cut and paste here for people who are not aware of the draft. This is basically what's in the document. So we first describe what is a disaster scenario, but then we look at the research challenges and we try to argue why ICN is good for these problems you have in the disaster scenario. And this goes back to what Dave presented earlier. If you are in a situation where even in military networks where you want to be able to prioritize messages, ICN is very useful for that, right? Dave was making a good example. By routing on the name, you can prioritize important messages. If you have congestion and the name says, okay, this is an important message, you let it through and you drop the unimportant messages. Obviously, as Dave was mentioned, in a military scenario, that's very easy. If you have a public network, like we were considering, that it might be, you know, users might cheat and you have these kinds of problems. Before this got adopted as a research group item, we got some comments from the DTN community because, you know how research community works. They felt we were digging into the turf, right? So they said, hold on, DTN is good for all of this. And we were in this document, we are arguing, well, ICN is actually a good starting point. You should enhance the DTN features. So we are looking at, we have a whole section describing why we think ICN is a good starting point and it needs to be enhanced with DTN features. And then I want to mention in section 5, actually, Dave, this also goes back to your presentation. We have a whole overview of existing research work actually addressing all these problems that you were mentioning. So for instance, we have reference to one research work where we actually did experiments how if you prioritize based on the name, you can actually get the important messages on average to the users while dropping unimportant messages, of course, assuming certain assumptions about mobility and all these kinds of stuff. So yeah, just for people who are not aware, so this has been around for a while, and I think many people here in the room have heard this. Over the time, we got various input from different people. Originally, this was an output of the Green ICN project, but we added a lot of comments from other people over the years. Again, there was a lot of feedback from the DTN community saying, hold on, you need to explain to us why ICN is actually useful and why not DTN solves all these problems. And we clearly feel that DTN doesn't solve all these problems, and we have a lot of text in this document saying why. And it recently, last year, got adopted. So latest changes in the last version, just really quickly, we removed the text from the Green ICN project because originally that was the output of this project. Now, of course, it's a research group item, so it should not be very specific. We made a couple of changes. We added some other research work, and maybe I should mention this to the research group. If you have a research paper accepted at a conference lately that you think addresses this problem, is a good example of how ICN is very useful in disaster scenarios, just send me the link, we can add it. We don't, and maybe this is what I want for the next slide. From the author perspective, but this is a question to the research group, we don't think the objective of this to be information RFC is to be an exhaustive list of all the work, but to give an overview of why ICN is useful. So we have a couple of examples of existing solutions from the research community showing how ICN can actually be enhanced with DTN-style features and be adopted to solve problems you have in these kind of scenarios. But if you have a paper that you think is a good example of showing how ICN can shine, I always say how ICN can shine, send me the link. We are happy to add it. But this goes back to what Dirk mentioned in the beginning. How do we move on with this document? So we actually also think it's quite mature. It has kind of a nice, we show the challenges, we show why ICN is useful. We have concrete use cases, and we show some examples that exemplify how actually, so some concrete examples from papers, research work, existing algorithms, showing why our vision that ICN is good for disaster scenarios is actually, we believe, true. So in the author view, the document is quite mature in achieving this objective. But I don't want to, I'm not saying it's done. I just have the question to the research group, how to move forward. I mean, we think, again, the objective should not be to have an exhaustive list like a living document, but rather to show by exemplifying what our vision is or the rationale. Yeah.
Okay. Thank you, Jan. So just quickly, chair hat off. So I think when we do these kind of documents, we do not necessarily say have to make ICN shine. We can also point at potential open challenges or things we may want to maybe improve.
That's okay. That's maybe a good thing. Open challenges is something we could add. Yeah, that's a good comment. Yeah.
Okay. Now, chair hat on. Who has actually read this latest version?
Okay.
Okay. Are there any comments to Jan's current assessment? So we need to get more eyeballs looking at this. Can we actually get some volunteer to say read the draft and maybe do a little review for the group? Okay, great, thanks. Eve Akbar, and I don't know your name. Can you come later after the session and then, okay, thank you.
Yeah, okay. Thanks a lot, that helps.
That's really great. So we got 3 people looking at it. That's good. Okay.
Yeah, thank you.
Thank you, Jan. Okay. So next is Akbar with a presentation on deployment configurations on ICN. It's in. Yeah.
How do I adjust this though? Dirk, no, don't there. Make it. Perfect. Okay, thank you. Thank you, Dirk. Okay, so our draft is, as the title says, their deployment configurations for ICN, and I'm presenting on behalf of my two co-authors, Dirk Kucher, who's here, and Dirk Trosen, who couldn't make it. Basically, what we did is we were discussing the Icnrg charter, and we noted that there was one important point that we felt could use extra input into the research group, and that's basically the charter item that talks about defining concrete migration paths for ICN, which avoid forklift upgrades, and also defining practical ICN interworking configurations with the existing internet. So this is actually text that's directly extracted from the charter. But we noticed actually there was not that much progress thus far on this topic. There was one draft from 2013 that started on this topic, but it was very preliminary, and for whatever reason they never followed up. So we believe this is an important topic to for the working group. Essentially, what we try to cover in this first version of the draft is some guidelines for an operator or somebody who's looking to deploy an ICN network, and also we've identified some areas that we feel need further standardization. And I think I was glad that Eve and some other people were talking about identifying standards work that have to be done, if I understood correctly from your presentation. So hopefully this fulfills at least part of that requirement or need. Our whole paper here, of course, is about deployment. So we're not trying to go back and redesign CCN or NDN or any of these other protocols. I think there's a lot of smart people already working on that. But we're just basically looking at, well, what sort of guidance does somebody need to deploy it? And first of all, we wanted to actually define what deployment meant. So I think it's self-explanatory, but just good to have it down. So in the context of our document, it's basically taking an ICN network, integrating it into the overall internet, and then having it do some useful work. So basically, not really a trial or anything, but really, what would we need to do to have somebody be able to send video, text, whatever content that they're wanting to send in a live environment through the actual internet. Okay, so the way we structured the draft was, first we talked about what we call configurations you could classify sort of a meta classification of various ways to deploy an ICN network, and then we talk about migration paths, meaning that what are the sort of obstacles someone would encounter when they're deploying ICN, and how would you overcome it potentially? What configuration would allow you to overcome it? So the first two configurations, again, nothing rocket science here. We're just trying to classify things, but it's important to be precise. So the first one was the original ICN vision, what we call the wholesale replacement, or actually traditionally called the clean slate approach, where I think that was the original vision, and it's a good endpoint for the vision of ICN, but basically it's assuming that you replace not only the IP infrastructure, but also very importantly the applications. So existing REST APIs, all these applications will also be impacted. So that's one obvious configuration, and that's the endpoint configuration of ICN, but probably, as we'll see, it's not how you would practically deploy it in the existing internet initially. The second one is probably the most popular approach today, which is ICN as an overlay, sometimes, of course, referred to as tunneling. So basically running ICN over existing IP infrastructure. The research group has already looked at and has, I guess, drafts and presentations on some of these classical ways. ICN over UDPs, I think the most common approach that researchers use today. You could also, I think the Cisco, part of the Cisco Park acquisition, I saw some nice press releases and discussions on naming, ICN names mapping to IPv6 addresses. Some of the European projects also had this convergence layer to map the ICN semantics, for example, to HTTP, assuming that HTTP is the new narrow waist of the internet. So this is two of them. Then we have two other ones that are more, I guess, less popular, but I think has a lot of value. What we call ICN as an underlay. So here we assume nominally with an island. So the island could be either at the far edge, for example, for IoT deployments, or for some cases it could be in the core network. But there we're assuming within this island, you actually replace all the IP routers and infrastructure, and you replace it with ICN infrastructure. But since you have to interface it with the rest of the internet, we assume you have these network attachment points or gateways, an ingress and an egress to the island. And in the ingress and egress, traditionally you would do things like map from, let's say, HTTP or CoAP IP onto a core ICN message, or vice versa. If it was an edge that was, let's say, an IoT edge that was fully natively ICN, from that edge, when you're leaving it to go to the rest of the internet, for the applications I'm talking about now, of course, you might have to map onto HTTP CoAP or IP, or I mean whatever the application happens to be. So this configuration, of course, gives you the native ICN infrastructure benefits, whether multicast delivery, fast indirection, etc., mobility, but of course still within an island, so you would have to have some gateway functionality at the ingress and egress. The final one, which I think is perhaps the most new but very exciting, and there was already some discussions during the Sunday workshop, if I remember correctly, on this, which is ICN as a slice. So this, this new concept of that the 5G people have, that you can have a virtual slice of the network. I think it opens up a lot of interesting opportunities, as some researchers have already identified, which is basically running that ICN within that 5G slice, and then you have things like service functions, service function chains that'll really help you to deploy it. So this is probably the newest idea, probably also maybe the most exciting at this point. Okay, now I'll talk about, I mean, of course we have more details in the draft, but I'll talk about the migration paths on a very high level. So the problem, basically we looked at, what we thought were the major areas, and what the problem was, and how you would have a migration path for ICN to really fully be integrated into the internet. So the first and most obvious problem is you have a huge pool of existing applications and services. Traditionally, many of them REST. Some of them for IoT, for example, maybe REST CoAP, or for the traditional web, it's REST HTTP. And the problem there is you have to somehow migrate that to this ICN infrastructure. So there's 2 points that we noted there. So the ICN as an underlay provides some backward compatibility, because you have the network access points doing the smart mapping. And on the other hand, ICN as overlay and ICN as slice requires changes to the applications, but then it probably opens up a lot of new innovation as you're going to start making the actual applications ICN native. Content delivery network, I think there's already a lot of good work. There was a very nice paper from the Cable Labs, for example, where they talked about building a CDN, purely native ICN. In our classification, it would fall as an underlay, and at the gateways you would convert from HTTP in the ingress and the egress. So I think the ICN as an underlay makes a lot of sense here. Edge network, here, anyways, I think it's self-explanatory, so I won't go into too much detail there. Here in the edge network, ICN as an underlay, or ICN as a slice. ICN as a slice specifically for cellular operators with their RANs and their dynamic network slicing that they're envisioning for 5G. And similarly for core network migration, ICN as a slice or ICN as an underlay. And then, of course, you can. There's a strong tie-in to SDN as well for this. Okay, just moving ahead here. So we try to do a very, I mean, I would say very light at this point, a survey of people who had run trials or experiments and have published results. Of course, as the note there explains, we didn't really focus on simulations. There's also a large body of work for simulations, but what we saw, is of course that you could classify all these existing trials into some of these categories. Right now, we just have these: ICN as an overlay, the FP7, Pursuit Sail, the NDN testbed, of course. And then ICN as an underlay, you have Horizon 2020, some of the Horizon 2020 projects, and also this Cable Lab content delivery system that's described in a nice white paper. And then let's say to the value added part of our contribution, meaning that we did some analysis, and what we see is really that the community at large, but specifically IETF/IRTF, could help promote ICN deployments by looking at some of the areas that are really probably bottlenecks at this point for future ICN deployments. The first here, there's a list of 6 items there. I'm not going to go through each of them. They're, I think, well described and self-explanatory. But the first one is, of course, what are we going to do with the REST APIs? And the way we structured the table was, on the right hand, we gave an example. So it's definitely not the final group, but an example of a group that might handle it. And in parenthesis, an example of work item that might be in the group. So for example, HTTP and co-op, and luckily we have Karsten here. They could, for example, those working groups could do support of ICN semantics in their REST interface, potentially. And that could be one way to address the problems with having non-native ICN applications, and then so on and so forth. I won't go through all of them because we don't have enough time, but the last one, for example, is the ICN mapping. There, I think it's another important one, mapping between HTTP and other protocols onto ICN message exchanges, the publish, subscribe paradigm, and also, of course, all the parameters. While, of course, we should, never lose sight of, we want to preserve the ICN message security as much as possible. I'll go to the last page and I'll do your comment. Okay, to wrap up, we're soliciting feedback from the research group on any other public ICN trials experiments that we can reference. I mean, the obvious gap in the document right now is CCN experiences. So if anyone, if anyone could give me a pointer or want to contribute to the draft, I would be very happy. And then the final question, I guess, and then I'll turn it to the chairs, is does the research group think the draft is useful? We believe it addresses the charter objectives, but it's the first draft, so we need feedback.
And I think you have some feedback.
Okay.
Hanno Flink from Nokia. Can you bring back the work package mapping? This one, yes. So if I read this correctly, you are proposing, please confirm me, you are concluding and proposing that ICN work is going to be split among these six working groups, and out of these 6, 5 of these working groups are new and require buff. Is that correct? I think that this is not a realistic proposal.
This is, you're right that that's what it says, but this is just an example. If you read the actual draft, it makes it clear that this is one way to address the standardization. I mean, before you leave, maybe you could say what you think is realistic.
Based on what we have heard today, for instance, we have seen that there are a lot of still open issues, but we are still trying to harmonize what is ICN, and now you are proposing splitting the work among a number, 5, 6 working packages. That there is no way that we can consolidate that into a single working architecture. So I think that at this point of time, the realistic approach is that it stays in a single place
Okay,
to
so,
ensure the coherence of the proposals.
okay, that makes sense. But the one thing before you leave, if it's a single place, it still has to be an IETF, right? Because what I understand is Icnrg is going to do some experimental drafts, but if we really want to influence the protocols for final deployment, that would have to be an IETF. So you're saying basically have a big single BOF working group, whatever, new effort in IETF when the time is right. I'm not saying to do this today, by the way.
Right, okay.
Yes.
I agree that if we want to have a strong industry impact, it has to be on the IETF side. But still, I think that based on what we have seen today, ICN is not yet for prime time. It will take a year or two before we can consider to move it into the working group, IETF working group. This is just, if you collect the statements or the presentations, you can come to this conclusion.
But by the way, I didn't have the temporal timeline when I said this, right? But I agree with you. But I wasn't implying to do this today.
Hi, but this is useful work. One section I would definitely, because you're looking this from more deployment perspective, and we're talking about ICN, and since we are doing things like name-based routing and exposing context into the network, so at least one section should be addressed is the privacy discussion.
Okay.
And that's fundamentally different from what you do today, right? I mean, everything is securely transferred. Again, of course, deployment, you can fundamentally goes more into depth on scalability and such too. But I think because these are the more concerning questions in people's mind, exactly how do you scale this thing if you really deploy it and if you really start putting states, name-based states into the network, right? So,
Okay, I agree.
Thank you.
Thank you.
This is Prakash from Cisco. Real quick to comment. This is very good document. In my opinion, this is trying to tackle the whole ocean. So you have so many areas to be covered. So maybe we limit the scope. So that way we are able to put more context into the document. And second thing, I felt like ICN as a slice, what you mentioned. Maybe we can have offline discussion, but ICN is not creating the slice. The slice created which can support ICN. So some verbiage required there, because we discussed at length at the ITU conference as well, and I think that is what was adopted, that a slice capable of ICN.
Okay,
So
that's what I meant, but obviously it wasn't clear. So I can talk to you offline, but we can take an action to clarify that.
Yeah. And one final quick comment. Instead of deployment options, because options are later part, if you put it like deployment considerations, then probably you'll be able to do more justice to describing the scenarios. Thank you.
Okay, thank you.
Hi, Dave Oran, chair hat off. So I have three really quick comments. The first is that I think this document is trying to do two things. They both have to be done, but maybe not together. And one is identifying what the gaps in the architecture and the protocols are that are barriers to deployment. And I think it does a really good job of that. The second thing it does is try to propose how to structure the work for filling those gaps. And I think it's somewhat premature to do that, because a lot of this gap filling is going to require new research and not just sort of like, we know what to do, we just need to get it standardized. So I think maybe we might, there's a tremendous amount of great stuff in here, but maybe backing off just a little bit from the, go full speed ahead might actually result in better progress. That's number one. Number two is that one of the things that we're missing that actually isn't in here that I think we really want to figure out is, how do you use ICN to deploy ICN? Right now, all of these test beds and all of these things, you turn around and say, well, how do I set it up? Well, I use PUP and MUT and all these IP tools running over IP protocols that institute VMs and get all this stuff running. And by the way, by the time you're done this, you have all this incredible amount of existing legacy infrastructure that are needed just to get your ICN network up and running. So if you're worried about deployment in some of these contexts, somebody should start thinking about how we bootstrap an ICN deployment natively with ICN. And that's a gap that I think could be added here. Then the third comment is just, I want to make an advertisement, which is on the last item on mapping with HTTP. Ilya Moshenko and I published a paper in the 2015 conference, which really addresses directly what you need to do to the ICN protocols to marry them correctly to HTTP in the web. And that's probably, I would argue that's a reasonably good, at least either a starting point, or people should explain why it's a lousy starting point for that type of mapping. Thank you.
Okay, thank you. On that last paper, Dirk actually had pointed it to me, but we didn't have enough time to add the reference and some of the key points, but we will do that. Thank you.
Okay, final question.
Sorry, I was like taking minutes.
Yeah, that's fine.
So I think one thing that is really missing in this document is about security. And I think in ICN, security is a fundamental thing. Like without signing packet or doing encryption of the packets, it's not ICN effectively. And how to do that, especially for the deployment, it's a huge question. And it goes way beyond all the listed approaches. So it has to be some item somewhere.
Okay, I agree. There was also a previous comment about privacy, so I think it mirrors that. Okay, so thank you. So we'll aim for an update.
Yeah, I think you get excellent feedback, so really constructive. Thank you very much, guys. Thank you, Akbar. And so next up is Ravi on IoT challenges and requirements.
Hi, so this is an update to the draft, which fundamentally captures the challenges of realizing ICN, IoT over IoT services on top of ICN. These are the authors who are contributing to this draft. So in the last meeting, prior to the last meeting, we had a call for adoption, and there were many comments from the chairs and others on the mailing list. And the draft has had several revisions, and we had that kind of address in the last revision. So I mean, you can look into this into that deck to see what were the comments and stuff. I'm not going to repeat it here. So the draft history, primarily, it's one of the older drafts that was earlier drafts that has been evolving from quite some time. It's a merger of two drafts. So in this recent one of the comments was that we don't want requirements draft. We want something that talks about challenges and design considerations. So we renamed this draft. So to basically make the discussion more focused. So this is the table of contents of the draft. So based on the feedback we got, we added, one of the main feedback was when people read the draft, it wasn't clear exactly why we need something like ICN for IoT. And so that's the reason we included one section there to explicitly motivate that discussion. Okay, and then we have a section on generally saying, looking at the requirements of IoT in general, because this is considering it's an informational draft, right? That's a good introduction to give to people who are reading this draft. And then we go in section 4, we discuss some of the weaknesses of the current approaches, which is more based on application layer based unified solutions. So there we also have one of the sections based on the comments was the suitability of DTN for IoT. It's not ICN IoT there. It's DTN for IoT. And then we have some of the section to basically highlight some of the features that ICN offers that fundamentally helps IoT. And then we go into the design considerations and challenges. So this is the draft. I mean, there'll be a lot of changes in the draft, but I'll not go into our small details. But I'll just highlight the main ones. So as I said, we introduced this new section here. So we have 4 use cases there: smart mobility, mostly dealing with basically smart ITS kind of systems, smart buildings, smart grid, and smart industry. Mostly looking at the industrial IoT kind of scenarios. So if you look at most of these, the contributions there have been saying that, okay, the main pressing points are about interoperability, energy efficiency, naming, security, scalability, reliability, availability, mobility, in-network computing, support, real-time control and data distributions. And the basic argument we make there is that this can be basically can be engineered or more efficiently using the features offered by ICN than over IP. Then we have the IoT architectural requirement section. So that's the just talking about general IoT architecture requirements. So there was, these are like, I just put some comments there and say how we basically have addressed them. So there's one comment on clarification of names. So basically we said, okay, they can be content, data, services, or devices, or a group of devices. Names that represent a group of devices, and saying that, okay, it also has, so there's other comment on saying that on some semantic requirements, saying that, okay, fundamental, the feature with ICN is that names are always semantic, either from a security perspective or from a human readability perspective or some structured sense. So then we have security, privacy. This discussion, this was based many comments saying that, okay, we have to promote the security privacy discussion. So that has been now that we have put it just after the naming section. Then in the resource constraints, we have, there was a comment on using some of the standard terminologies for depending on how resource rich the constraint device are. We have done that. Communication reliability, there was a comment on, we had kind of said, okay, something like a role routing model may not be sufficient, but if you want to do something like device to device communication, you don't need to go always through the root, but you can kind of do something like a mesh. So, but anyway, we have kind of toned down that comment. We said that, okay, it's one of the requirements is that it's good to support those kind of mesh kind of communication models. Then we have this ad hoc and infrastructure mode. The comment was that, is this distinction required? So there, I mean, the reason why we put that there is because we want to use, basically it's for having a unified IoT architecture using ICN, and we want to use ICN both for these kind of infrastructure mode where you need scalability, low latency, but also for ad hoc modes where you need things like efficient neighbor discovery. So if we still kind of retain that, but if there is saying that, still comment saying that we shouldn't make that kind of distinction, then we can think about that. Unified architecture. So this was previously we called this open API. So the main goal here was to address this kind of heterogeneity in the systems, interoperability. So that was one of the requirements we wanted to put there, that you need a system that offers standard API for naming, discovery, push-pull, pub-sub, some of the security mechanisms compared to all the kind of siloed and proprietary systems we have today. Then section 4 is on application layer, unified. So this is basically we had earlier called overlay-based unified IoT. So probably we were using the wrong terminology there. So we corrected it. We call it application layer unified IoT solution because most of it is going through some application layer gateways, pushing into a central cloud, and that's where things are getting processed. We have one section for DTN for IoT. There is some work on looking at how DTN can be applied for IoT, but the basic, I think there's been discussion on DTN and why DTN is not ICN and so on and so forth. So we have added similar comments there saying that the DTN bundle protocol, though it provides some features of decoupling senders and receivers, fundamentally it's still a host-centric protocol. But with ICN, we are mostly looking in terms of information naming, discovery, dissemination, and mobility. So a lot more features that we provide with ICN that probably DTN doesn't offer, or since considering that DTN is more looking at more disruptive based scenarios rather than ICN, where we consider things are more stable. That's the kind of, it's more suitable for general networking scenarios than what DTN is. So there's one section on advantages of ICN for IoT, comment on security and privacy. So here again, this was missing in this section. So we have introduced the new subsection, and we have basically added all the features that ICN provides in terms of name data integrity, authenticity, and so on and so forth. But even in constrained environments where you may not want to do security operations on those embedded systems, you could offload it to the gateways. Then there is an ICN design consideration. So this section, well, again, we have elevated it in the challenges section up and contributed. We have more new contributions in here. Because we said, okay, there's challenges, security, privacy, you have energy efficiency requirements, long battery life, and some of the ideas on basically saying you can use physical wireless signal for security features rather than doing this cryptographic operations. And then some of on the infrastructure side, of course, there are many vulnerabilities. Some of those have been also expanded upon. Privacy of data, considering it is collected, and of course, privacy is a big concern, and so we have some challenges related to privacy too in this section. In the ICN design consideration, again, there are again few of these things, caching and storage. So there was a comment on removing explicit references to capabilities of constrained devices. But there was one comment on saying that we need more examples that we missed out here, so we will address it in the next version. Mobility management was clubbed with routing and forwarding, and the comment was to separate it out, so we did that. Communication reliability, we need more specific challenges here. So I think most of the features here we have put there was, and still probably what was added is still from that infrastructure perspective, multi-homing, caching, stateful forwarding, and so on and so forth. That gives you that robustness. We have also added some of these things like opportunistic store and forward mechanisms that you could use in the critical points in the network, like in the last mile. Again, these things bring some control and forwarding overhead, which have to be considered, which might kind of affect the overall throughput of the applications. But I think there is still scope for putting a little more on the constraint side to improve communication reliability. We'll definitely work on that. And this one, we had one on energy efficiency. So we expanded this from the perspective of basically basically one of the costs for the embedded system is the cost of transmitting the bits itself. And so when we are actually using this long names that will cost for the IoT system. So we added some text on basically using kind of shorter local names here and fundamentally do some kind of translation in the aggregator gateway points to alleviate, to help with this, the whole problem of energy efficiency. So this is all we had improved upon, and the new contributions and all. So we see that I did mention that there are still some points that have to be addressed. We'll certainly address that. We hope this can at least be taken up as a RG document and get more comments and basically do whatever is required to help the community to benefit from this work. Thank you.
Okay, thank you very much. Comments, questions? Then I have a question to the audience. Who has read this latest version of the draft? Not that many. I think you should really do this because as ICN and IoT is becoming one of the most researched and hottest topic in the ICN currently. And I think we need somewhere to collect all these basic issues and capabilities of this combination. And I think this is a reasonable starting point. But if people have better ideas and other ideas, those are of course welcome. But I would really like to have more comments on this. I'd like to see them on the mailing list, and hopefully we can move this forward if people agree with that. But let's have more people read it. Are there anybody willing to review this document? Yeah. Okay, so we have. Make sure that the note taker gets your name in. I'll also do. Actually, I have some quick feedback. Yeah, but let's do the reviewers offline. Just quick comments because we had this thing-to-thing discussion that was really good, and they are going to write up the summary of these. I think a lot of those things could be taken as inspiration, and some of it moved into this document. One thing typically that's missing in this one, and that Eve also talked about today, is this when you have large amounts of data at the edge that is too large to put up to the cloud. That type of use case is missing.
Yeah, we do address that we have a challenges section for in-network computing. So the whole idea is to do some kind of hierarchical processing to reduce that amount of data. So
yeah,
we do have, but we can definitely.
It should be more highlighted.
Sure, yeah.
Okay, thank you.
Thanks.
Okay, next.
Okay, thank you.
Okay, so this draft is for CONTRACE, which is a trace router facility for content-centric network. So I'd like to present a revised version, but last time I already mentioned the detailed story and the detailed spec. So today, mainly, I want to discuss a little bit about the security. So this is a CONTRACE overview. So CONTRACE itself is can be a protocol analysis tool and also OEM tool. For the protocol analysis tool, we can get the caching point, which is a router or publisher, and then we can calculate path stretch, and we can measure hop count and RTT for content retrieval, and we can obtain the situation of the cache distribution and the cache hit ratio. And as a OEM tool, we have a good chance to make a operation to clarify the cache lifetime or expiration time. And for monitoring purpose, we can monitor CS usage at router, number of received interest per cache, and we can confirm whether multipath forwarding is active or not. And for troubleshooting, of course, it's possible to get the information of the availability of caching routers and publishers. CONTRACE itself has two messages. One is a request message, the other is a reply message. Request message consists of a fixed header, request block TLB, report block TLB, and name TLB. So the request block TLB and report block TLBs are newly defined for CONTRACE. The CONTRACE reply message, it consists of a fixed header, request block TLB, report block TLBs, name TLB, and also a reply block or subblock TLBs. This TLBs are also newly defined in this draft. But every TLB or every format is compatible with CCNX version 1.0 TLB format. This is a CONTRACE basic behavior. So CONTRACE user, usually can be a consumer, can send a request message toward the contents holder. He doesn't know who is the contents holder, so he specifies the content prefix name. Then this request is forwarded in a hop-by-hop manner toward the contents holder. And if, for example, this router C is a caching router for the specified content, then he reply back to this consumer. And also this support multipath, so this single request message is divided to the different paths toward, in this case, toward the publisher. And publisher can just reply toward the consumer as well. So from here, I'd like to talk about the security considerations. Of course, the countless or itself is actually really similar to the trace route facility, unicast trace route facility, and also it's really similar to the multicast trace route facility. So many parts are copied from trace multicast trace route and named mtrace, the specification. So it's really standard protocol. We can just gather the steal the good specification from mtrace. But for the security consideration, of course, we should care about the security. So in this draft, we already mentioned that these security considerations must be, well, considered. So policy-based information provisioning for request. Router can reply the contrast reply with the admin prohibit return code without appending any reply subblock or block TLB if they want to inform some information. And the permission whether all partial deny can be defined at routers. What is all partial deny? All means the all cache information is disclosed. Partial means cache information with some particular name prefix can or cannot be disclosed. Deny means no cache information is disclosed. Such kind of information should be configured in each router or publisher. And the filtering of context user located in invalid networks. Routers may support an access control mechanism to filter out requests from invalid context user located in invalid networks. This is something like a condition and requirements. So this draft itself doesn't show some specific security mechanism or security algorithm, because this kind of discussion can be mentioned in a separate draft. So in this draft, contrast draft, we can just say we should care about this kind of situation. So topology discovery. If a network topology is a secret, contrast request may be restricted at the border router of the domain using the admin prohibit return code. Characteristics of content. If publisher or content information is secret, content request may be restricted at the border router of the domain using admin prohibit code. Shortening contrast reply timeout. Routers may configure the shorter timeout value to timeout a request. Limiting request rates. So routers may late limit contrast requests by ignoring some of the consecutive message, because this can become a very nice DOS tool. So the router can can configure some late limit configuration. As well, limiting late replies. Routers in the traced path may rate limit contrast replies as well. And adjacency verification. This is actually, in general, difficult in the CCN world. Forwarding contrast message given from non-adjacent neighbor routers or routers must be prohibited. But actually, there is currently no way or no mechanism to verify he is really valid neighbor router or not in CCN. So maybe this kind of discussion should be, again, discussed in a different or separate draft. And we have been actually working as a different topic. We have been working for this kind of hop-by-hop security mechanism in an academic paper, and we plan to submit as a different internet draft. So if some of you are interested in this kind of security mechanism, I'm really happy to collaborate with you. So anyway, so such kind of a new TLV for adjacency verification using hop-by-hop TLV will be defined in a separate document. So we already discussed about that kind of security considerations. And also the good news is we already implemented this contrast. So this is actual screen capture. So you can see the contrast command and contrast with some specific name. So this is a simple test bed topology. Here is a consumer and their publisher P, and they are routers. And there is a caching point for CCNX News Science, for example. P2 it is the owner of this content. So you can get the reply from publisher 2. This path goes to publisher 2, router 1, router 2, and publisher 2. Then publisher 2 just return toward the consumers. And this signs that this information is given by publisher, so not the intermediate router. their RTT, their hop-by-hop delay, and this is RTT given from publisher 2. And if you don't want the content information, just want to measure the performance of the network, you can specify, for example, n, minus n. So, and in this case, the router 1 has a multiple pass for this prefix, then request is divided toward R2 and toward R3. And so you can receive the reply message from router 2 and router 4. And the RTTs, you can measure, you can see the RTTs. And there is no cache information in this output because you specify minus n. And if you do want to see the origin, which means a publisher, not in caching router. For example, in this case, you may want to measure the path stretch. In that case, you do need to get both information about the closest cache point and also the publisher's location. So you can specify minus O. This requires origin, which is a publisher must reply. So you can get the information from publisher, and you can get RTT, and this signs shows publisher's reply this information. So in summary, contrast which is compatible with CCNX version 1.0 TLB format is a really powerful network tool providing various information such as caching point, publisher, path stretch, hop count, RTT, cache distribution, hit ratio, lifetime, expression time, CS usage, number of received interest. So you can also calculate or expect population. And the security consideration, of course, this is important, even though this is not a standard draft, but we should care about the security consideration if we need to consider or to have some potential situation to deploy this tool in the world, in the CCN world. And we already discussed, of course, we may lack some point especially for the security issues. So if we have some interesting security comment, I'm really happy to include that kind of security considerations to make it mature, And the experience with the running code, actually the contrast, we already developed the previous primary work of the contrast. It's published in a communication magazine 2 years ago, actually. But this contrast is a separate implementation, which is working with CCNX version 0.8. So contrast daemon can just in parallel working with CCND and make some interaction with CCND by changing some CCND's code to get the CS information. But now this new contrast is completely inside the protocol, inside the CCN protocol. So, and this idea is also implemented and already tested. So ongoing work, last time I got some question about ICN trace or other trace route facilities for ICN world. And actually I talked with ICN trace first author, Spiros, who is in UCLA's guy. He's now interested in our contrast. I don't know what he will do for ICN trace, but he's interested in the contrast. So now he have been working for the new specification for contrast NDN. And unfortunately, I cannot submit before the submission deadline of this IETF, but I'm still working, we are still working, and in a separate document. Actually, we tried to merge everything, but the story or the packet format is completely different, and story may be also different. So it's a very, very busy, I made a very, very busy document. So I now make it split to the different draft, and we have been now working for contrast NDN, and in the very future, we will submit the contrast NDN to this research group. So I think this is really useful for everyone. So maybe it's now time for asking research group draft. Thank you.
Thank you very much, Hitoshi. Quick question. So you said it's really useful. Is the software actually available?
Yes. In near future, yes.
In the future, okay.
In very near future, yes.
Okay, looking forward to that.
Actually, I have a few questions. One, what is the relationship with the Cisco work? And you mentioned the Spiros. So while he was in Cisco interning, so he was working on a draft.
So
trace route.
I see interest.
How is it related?
So Icnrg is more on FIB. So more on FIB. This works on both FIB and CS. And Icnrg is writer and something like really similar to ICN ping. So it's more on FIB, just to measure the performance of network.
Okay, so maybe Dave, you want to comment on what is a long term? Is there, or is just all experiments?
Sorry, what do you mean?
Well, we have the ICN ping and traceroute drafts. No one's here to discuss them this week.
Oh, okay.
So I don't know quite how to respond. It would be really nice to have one traceroute answer, right, and not two. So, maybe maybe we could encourage people to work together on that.
Yeah. Another question is related to this draft. Why it needs to be a separate message?
Separate message means.
I mean, why is it not interest data exchange and there's some application effectively running on each ICN forwarder?
So independent, for example, independent DIM. So like a previous hour, I said this one. This one is an independent daemon actually, daemon implementation. This daemon implementation has its own message without using any CCN's message like interest or something. You're asking this kind of situation? Why this is?
No, why contrast requires introduction of a new message type?
Because this is part of CCN now.
But it's relevant. It's still, even if it's part of ICN, you can have it request as part of interest message and reply as part of the data message.
Yeah.
Otherwise, like all applications will introduce their own message types?
Well, no. Of course, this behavior is really similar to the interest data communication. So request is something like an interest sent toward the publisher, and the reply, like such as a data, can just get from. So PIT management, FIB management, everything's really similar. But the big difference is that we should distinguish this is not a regular interest because this is trace route. So if we have a multiple trace route request, if this is the interest, then everything is aggregated. And the PIT is removed if one request is given.
Okay,
one reply is given.
I'll give one comment on this. This is purpose of naming conventions. So you define the naming conventions for the countries, and then there's a daemon that operates in this namespace. But just want to additional one point. You mentioned that you're not planning to include security kind of a design or proposal as part of this, and I think that's not correct. Well, it should not be just mentioned. Oh, there's the we need to consider
I know.
this.
I didn't say I don't care. So please address my security issue. Come on, I didn't say so. If possible, of course, I do hope I can add some select solution. But in my mind, many solution issues really common, not only for countries. So security discussion have a common draft is really important, not only for this one, not only for improving the quality of these countries. So having, of course, if the security part, some security issue is really rely on or depending on these countries, of course, we must address, I know. But the many parts seems to, for me, is really common, and we should have a good security draft, and we can just refer, hey, we have a very nice security draft, and solution can be just, we can refer.
So closing the line after Dave.
Bert Wijnen, Huawei. So the term Contrace Act already says, and I think your previous discussion with the previous question sort of gave me the answer, but I just want to make sure I did understand that properly. So this indeed looks much more like a ping or a trace route than it is like in-band telemetry. In IPPM, we are actually working on in-band telemetry because, if you do ping and trace routes, there may be, systems that implement like favorable working around the ping and trace route so that your response times look great, but the actual data paths do not get the same response time. And so is this indeed more like trace route, and if so, would some telemetry related activity be interesting here as well?
No, it's really just following the traditional trace route facility.
Right. So you do, and that's why you do extra packets.
Yeah.
So they could be treated preferentially compared to other regular data.
Yeah.
Would you be interested in some telemetry work?
It's interesting. Of course, it's
Well,
interesting. Well, but okay, I'm interested in.
All right. I'll
Okay.
Thanks for bringing it up.
So a couple of things. First, Dave Oran, first with chair hat off. One is that you mentioned that one of the reasons you went to a separate type of packet was because of the problem of interacting with interest aggregation. And the other draft also faced that and said, well, the right way to do that is some separate indication in a regular interest message that or via the way the names are constructed that you don't aggregate these interests. So for example, if you put a nonce in each version, it will, from each, they won't get aggregated. So I think it's important to see more justification for a separate message type than simply to get around the interest aggregation problem.
Okay.
Second comment, chair hat off, is that there's a lot of commonality between this and the ICN traceroute draft from Spiros and company. But there are some differences. It would be really nice if you could talk directly together and see, at least you could post something in the list that explains what's common and what's different, and maybe we could talk about whether we need both or one is a superset of the other going forward. And then with chair hat on, this is part of getting the management instrumentation part of an ICN going. So this is a pretty important area, and I'd like to really encourage people in the RG, not just to work on these things, but to fill it out. I mean, Barrett mentioned a whole bunch of in-band instrumentation and measurement stuff. It'd be really unfortunate to reinvent all that from scratch. On the other hand, there are probably some specific ICN-specific approaches that one would do differently in an ICN network. So I guess this is a chair saying, hey, if you're doing work in ICN, and particularly the research side, this could result in both practically useful and publishable results. So thank you.
Okay, so Alex, we have to move on, really. No, sorry. So Cedric, can
make it on the list.
So next is Cedric Westphal on challenges in networking to support AR and VR.
Have to stay in the box.
Yes, please stand in the box.
This one.
Okay. This people
cannot see that, but anyway, let's get going. Next slide, please. So this is. Do I switch? Oh, this is what you're doing. Yeah. I thought it was a pointer.
It's also a pointer.
It was.
It's also a pointer.
Yeah. Okay. Yeah, so I wanted to talk about and gauge kind of interest on this topic. I mean, it's and so augmented reality, virtual reality is something that is kind of really gathering momentum now, and it's going to create a tremendous growth in the traffic. And there are multiple phases in the deployment of applications in that space. There's going to be some kind of phone-based application that we're going to work locally. And then there's going to be some more sophisticated application that require you to wear some kind of head-mounted displays. And those head-mounted displays could be connected to a local resource like the Oculus Rift and this type of stuff. And then you're going to have some stuff where the head-mounted display is going to be connected to a network. And it's going to stream the traffic directly from the network over to you. And it's going to create tremendous growth in the amount of traffic. So this is kind of the projection, and the takeaway from this, it's going to grow really fast, $100 billion market pretty soon. And so there's going to be a need to support this, both in the infrastructure, in the handsets and devices, in the applications. What I'm talking about here is some augmented reality, which is a system that inserts a virtual layer over the user's perception of actual objects that's looking in the environment and enhancing that environment with some layer of annotation and added features onto the real environment and the virtual reality. It's a system that places the user in some kind of synthetic virtual environment that only requires a coherent set of rules and interaction within this environment and the other participant in the environment. And there's a whole spectrum in between those things, of course. So what are the use cases and how do they impact the network? The use cases for this, and I made a list here, and this list is not exhaustive, and it's just what I came up with. For instance, there's no looking at it, in between the time I send those slides and the time I'm presenting them, I could add military applications, for instance, that we've seen in Dave's presentation earlier. So the application on the implications on the network are goes from very low to very intensive. So if you have some kind of, if you want to extend a display onto your screen display, like your programming environment, and you put that into, instead of having 3 screens in front of you, you want to have like the whole visual space in front of you, you can do that. And, just connecting your some head-mounted display to your local network, and there's absolutely no networking requirements. That's the first step. Then you can have some other steps where you enhance, you have some experience where you're going to place yourself in some kind of retail environments, museum environment, real estate, education, classroom. You create the experience of being in a specific area. And so you can do this with files that are stored locally or that can be prefetched, put ahead of time. And now the question becomes, how do you move this virtual environment into the display? So do you use some kind of network of caches? Do you use some prefetching function? Do you cache those files, those content objects, next to where they're going to be used, and this type of stuff. Other application is you can think of is some sports. So now you can participate remotely in some live event, and that adds a dimension of real time or pseudo real time. It could be delayed by a few seconds, few minutes from the live event, but so there's some kind of timing aspect to it, and you have an aspect of scale of the stress on the user, which is how you're going to distribute that live content in a timely manner and to a large number of users. So now it's like, are you going to be able to do some multicast? And how are you going to support the distribution in almost real time to a large number of users? You have gaming applications. You have some medical maintenance application where you want to do some overlay instructions on top of some equipment. And those are some kind of narrow scenarios where you're going to have synchronization, real-time, round-trip time requirements, very stringent synchronization requirement, very short round-trip times requirements, both up on the display, on the rendering, the view you want to do, the augmented reality, and both on the sensors that are capturing that motion and that are the input of the motion to create that view. And then some kind of, like the augmented map and directions environment, where you're trying to observe some environment, process it, annotate it. So there's a lot of processing you have to upload a stream of information from the device that is capturing the environment, processing that information, and then returning some kind of rendered version of that environment onto you, and some kind of annotated version, maybe doing some face recognition on top of this, doing some annotation, some pattern recognitions. Yes. Okay. Yeah, well, anyway, so a wide range, so let me skip a few of them. So 5G networks, we talk a lot about them, and they're going to deploy and increase the bandwidth a lot and reduce the delays a lot. But the question here, so I like this slide because it's the kind of the space here. You have 2 dimensions. You have the bandwidth that is available to, and a delay that is available to you. And the white box here is where we are now. The gray box here is where are the services that would be enabled by 5G. So everything that's not in the white box cannot be delivered on the current networks, but would be delivered by 5G. But augmented reality, virtual reality, they are kind of at the edge of that gray box, and they kind of they're in that gray box only in, like, you know, the ultimate in the best conditions of the network, and not in the most condition. So basically, in terms of bandwidth, let me go back. In terms of bandwidth, you can do some calculation, and I'm not going to ask you to read this, but the calculation is basically the bandwidth. Some people, you know, that multimedia expert compute you need like 5 gigabits per second of network throughput to get a real good quality virtual reality that doesn't give you, or video streaming that doesn't, 360 video streaming that doesn't get you seasick. And 5 gigabits is less than, you know, it's way outside of that gray box. For the delay, it's the same thing. I mean, if you look at the delay, if you just look at the speed of light, you have 13 milliseconds just to go across the United States. So you're going to have some, you know, careful consideration as to where you place your servers and your function, just for that to work as well. And anyway, so let's get into some kind of a net. How much time do I have? 5. Well, I hope I should be able to do it. So in terms of the network architecture issues, the 5G, what I've said so far is that 5G was going to face an uphill battle in delivering AR/VR as application because it's very resource intensive. So the question is, how are you going to do integration of those AR/VR application into the network versus are you going to do them as an over-the-top applications, and are you going to do some kind of application-driven networks, or are you going to write a dumb pipe at the network level and hope that there is enough resource? How can you guarantee QoS, low delay, low jitter? So can you do 5G slicing, for instance, dedicated to AR/VR, and can you do the placement of function at the edge of the network for low latency? But the kind of claim here is that, of course, information centering network would be the network architecture that would help and would be required to be deployed in order to provide those services. That if you just if you don't have network support for AR/VR application, you're not going to be able to deploy this application on a 5G network. So and the reason for this is that you have this content awareness, of course, and you can take action based upon specific content requirements. You have the native support for multicast, which is embedded in ICN, which is essential for multi-party AR/VR application. And there, you know, as I described earlier, there are a lot of those use cases that are going to include sports events, gaming, video conferencing, this type of stuff. You also have the fact that if you share some event, like if you have a 360 view, you might be able to construct that view from multiple tiles, and those tiles could be shared between different users. So you can have, and if you have a specific naming convention for this naming of tile, for instance, you know, for a specific field of view with a specific resolution, you might be able to share this among multiple users. And then you have enhanced content distribution in ICN from, you know, for the potentially large files that you need to distribute. So for that real estate application I was talking earlier, or like 3D models for some, you know, unique models for VR application. And of course, you have the edge caching and the edge function that are prominent in ICN for the low round trip times. So the question here, and kind of the thing is I'm interested in exploring, is would ICN provide better support for AR/VR than current IP architecture? And so my last 2 slides is a list of research challenges, and then I open the question. But the question is to identify network architecture that can deliver better support for AR/VR in 5G networks. Identify what functions are necessary into the network and how to integrate those functions with the network architecture. Identify what are the interfaces that are required between an AR/VR application and the network. What you know, can it function purely as an overlay, or if you integrate it better, can you get some help from this infrastructure for caching of the element for multicasting? traffic engineering, QoS, etc. So identify the proper naming semantics to expose at the network layer enough information to allow the sharing of data in between several virtual environments. Identify the coding also, so that those virtual environments can be packetized into multiple cells units, some tiles that can be recomposed into a session, but can be shared between multiple users. Can you characterize the motion prediction and the corresponding network protocol to assess whether this information needs to be shared with infrastructure? What kind of rate adaptation mechanism we want to do is like, can you do something like Dash for AR/VR? What is the caching policies for those AR/VR content? How do you specify QoS? In the interest data, there's always a handshake. Can you use that handshake for QoS setup as well? Can you characterize the reliability requirements of AR/VR session at the network layer? What kind of transport protocol? Because how are you going to pipeline those interests, for instance, for support AR/VR, and what kind of security security mechanisms, and many other resource issues. And this is my last slide. So did I do it on time?
Yes. Thank you very much.
So basically, the question is I'm putting together some kind of document that encompass that kind of rephrase this, and so it's going to be submitted soon. But I just wanted to go if there's any interest in looking into those type of issues, how there could be like support for, and actually there is some work, research work on that topic for support for NDN for some AR/VR application I've seen from Jeff Burke and other stuff. So if anybody's interested in this, try to gauge interest. And Hanu is interested.
Yeah.
Well, good. So.
Thank you, Cedric. I think that there's big interest, and we have been discussing this a little bit before.
Right.
So you're saying you want to submit a draft on this?
Yeah, so I mean, basically, so the paper that is linked on the wiki was some kind of I'm merging this. I'm like porting this into some draft. There's also some ATIS standardization group. The Econ group is looking at similar issues. So.
Yeah, so if people are interested, talk to Cedric, and let's do something more on this at the next time in Prague.
Right.
Thank you very much. Sorry, Prakash, we can't have your presentation out of time. If people are interested, it's already in the material of the Sunday meeting, so check it out. Thanks, everyone. Final remark, we're going to have a meeting at the Prague IETF. So we are currently planning for a full Sunday meeting and something during the week. Details will be discussed on the main list. Thanks again for coming. It was I think, really interesting. Lots of new inputs, great feedback. Thank you all. Goodbye. And there's also going to be an Icnrg meeting in Berlin. Just remind me.
In conjunction with the ASEAN conference.
Oh, hi.
We're all still here. We're all still here. Yeah. Oh, so your Cisco contract is over now? So, yeah, I mean, I'm having a great time. Hi. Yeah. How are you? Well, it's registered with the state of Massachusetts. Yeah, now I remember. Yeah. I was a sole proprietorship. No, I mean, so Thomas and I. No, it's a sole proprietorship. Yeah, I think it's different. Yeah, just, whatever, you know, it's just air cover for my, for my
Yeah, mainly where like focus on the research.
So let's see, I've got well, yeah, right. I'll do okay if either one of those startups, you know, it's all like, yeah. Let's put it this way. The payoff of that is not in my financial. I'll be asking everybody. Not the university.